So today what I want to look at, we've looked at area underneath the curve, but today what I want to look at is actually the area between two curves. And you can see the picture that we have here of f of x and g of x, and the area that we're looking for is enclosed by where those curves intersect, okay? And there's a couple of different things that we have to consider when we're looking at this type of a thing, okay? But we're gonna, first of all, I want you to understand the process and understand the kind of formula that we're going to use for this, and then we'll do some practice with this, okay? So first of all, you need to identify, if you're trying to find the area between two curves, you need to identify the region that you're dealing with. And to do that, you have to figure out where they intersect. Okay, where do our functions intersect? And now here's the thing. They might intersect at more than just two places. Okay? If they only intersect once, then the region is going to be infinite. Okay? If they intersect twice, then you have one region like you have here. However, we could also have a case where, for example, maybe f of x looks like this, and g of x looks like that. Okay? So you'll actually have three separate intersection points. And I'll actually show you here in a second how we could handle that as well, okay? But you have to find those intersection points first of all, okay? So here's, we'll call that A, B, and C. Now, the next thing you need to do is figure out which function is greater within the interval that you're dealing with. In this first example that we have, f of x is above g of x, okay? And what you can do with that, if you're not sure, is just pick a number between the two intersection points and plug it into both of the functions for x, okay? So, you know, if a and b were, 1 and 5, pick a number between 1 and 5, plug it into f, plug it into g, and that'll tell you which one is greater between the ends of the interval, okay? And that's important because what we're going to be doing is we're going to then find the two integrals and subtract. Or, as you can see the formula we have here, we can find the integral of the function minus the other, okay? Yeah?
So greater in terms of which one's on top?
Yes, yes. So, as you can see here, what we're dealing with is, I'll just zoom in on this a little bit. G of x, we know, gives us the area underneath g of x between a and b. Okay, the integral from a to b of g of x is going to give us that area right there. Okay, that's not the area between them, obviously. But then you have the integral of f of x from a to b. That's not going to give you the area between them either. It's going to give us the area all the way down to the x-axis. And this is why it's important to tell which one's on the top and which one's on the bottom. Okay? Because if we take the integral of f of x, the part that we don't want is equal to the integral of g of x. So that's why we subtract them here. The integral of f of x gives us this whole region. The integral of g of x gives us the part that's outside of the two. And when we subtract, we have just the part that's in between them. Okay? Now, based on our properties of integration, rather than finding these two integrals separately and subtracting the results, we can go ahead and put them together, and we have the integral from a to b of f of x minus g of x. So you can subtract the functions first, then integrate.
I remember like this when I read the chapter, like I see that this says we should use the top function to like the integration of the function on the top minus the integration of the function on the bottom. But how do we know which one is the top one, which one is the bottom one?
Just plug a number in between a and b. Just plug a number in and see which one gives you a higher number.
Okay.
Yeah. If you can see them, then it's easy. But if you can't see them, or you don't know what the graph looks like, or you don't, it's maybe a no calculator portion of the exam or something like that. You'll have to just plug in a number.
Okay. So for this one, which one is the higher one? The fx?
Yeah, for this one, just based on the drawing, f of x is above g of x. Now, the one down here that I have, this one is a little bit different because we have two different intervals that we have to deal with. Okay? So, first of all, we need this region here. And that's going to be the integral from a to b of, which is it going to be? F of x minus g of x or g of x minus f of x? Very good. F of x is on top, so this is going to be f of x minus g of x dx. Okay? But then we need the area of this portion over here. We're going to add to it, and that's the integral from b to c of, there we go, good. G of x is on the top in this interval, so it's going to be g of x minus f of x dx. Okay? So it's a pretty simple formula. The challenging part really on this is just finding those intersection points and determining which one's on top. Okay? So let's try an example of this. Here we're given a diagram, okay? And they actually label on the diagram where the intersection points are. But let's say we didn't have that. How would we find those intersection points?
Plug in 0.
Huh?
Plug in 0.
Make them equal to each other.
That would give us zeros for each one separately.
Make them
Oh,
equal
the
to each
intersection
other.
of
Yeah, we want the intersection of the two together, so we'll make them equal to each other. Since they're both equal to y, we can set x squared plus x minus 2 equal to x plus 2. Okay? So we have a quadratic, we get it equal to 0, and we have x squared minus 4. So we add 4. X squared is 4, so x is plus or minus 2. And you can see here on the graph, they've labeled these for us. Okay? So I know I'm going to be taking the integral from -2 to +2. The key here, though, is to figure out, am I going to do x plus 2 minus the x squared plus x minus 2? Or other way around. Okay? So again, imagining that we can't see it on the graph here, we can always test a number between -2 and 2. So I'm going to pick 0. And if I plug in 0 here, I get a +2. But if I plug in 0 over here, I get -2. So that means this is on top between -2 and +2. Okay, so now I can put my top function, x plus 2, minus the bottom function, and that's what I'm going to take the integral of. Okay, and what I recommend is that you go ahead and simplify first before you take the integral. Okay, so it's the integral from -2 to 2. This is going to be a -x squared, x minus x is 0, and 2 minus a -2 is 2 plus 2, which is a +4. notice how, since I did the subtraction, I actually ended up with a little bit simpler of a function to manage. Okay? So we have a negative x cubed over 3 plus 4x, which I am going to evaluate from negative 2 to positive 2. Okay, if I plug in a positive 2, I get negative 8 over 3 plus 8. Minus, if I plug in a negative 2, it's going to be a negative 8. So positive 8 over 3 minus 8. Okay, so I get a negative 16 thirds plus 16. Negative 16 thirds is a negative 5 1/3. So that's going to be, this is going to give me 10 2/3 as the area between them. Okay? So all of that's review. That's just fundamental theorem of calculus. But the new portion here is finding these intersection points, setting the bounds, and then figuring out which one is on top, which one is on bottom, so you can subtract them properly. Okay? Now here's a little tip. If you get to the end with just one region, if you get to the end of finding the area of that region and you end up with a negative, guess what? You just got your top and bottom flipped. You don't need to redo the whole thing. Just identify that, this should have been reversed, therefore my answer is positive 10 2/3. Okay? The area between them will always be positive. So, again, that's a way to catch a little mistake, but it is just an easy fix. You just identify, I needed to switch these, and all that's going to do is change it to a positive. Okay? All right. Now, this is another example of kind of the same thing that we're dealing with, or that we have dealt with, and that is the total area of the regions contained by the function in the x-axis. Okay? Now, we can treat this just like what we were doing. Okay? Because the x-axis is simply the function y equals 0, right?
Yes.
So, to the left here, we can see that the function is above the x-axis, so it's going to be this minus 0. Okay? For total area, on the right-hand side, between 0 and 1 here, the x-axis is on top, so it's 0 minus the function. Okay? This is another way of handling that. Remember we said if it's below the x-axis and we're looking for total area, you just make it positive. Well, this is why you can do that, or another way of thinking through doing that. You're thinking of it as the area between f of x and the line y equals 0. Okay? Now, again with this type of a thing, you do need to figure out the zeros. Again, assuming that we weren't given the graph here, we would figure out the zeros. So I see there's an x in common, x squared plus 2x minus 3 times that x. And then I can keep factoring this. What does that factor into?
1 and 2.
No? What does x squared plus 2x minus 3 factor into? X plus 3. Yeah, and that'll give us a plus 2 in the middle. Okay? So that's how we know the zeros. The zeros are at x equals 0, 1, and negative 3, just like they have pictured here on the graph. Okay, you're not going to be given that, even most of the time. Okay? So, now we can find our area, alright? What's the first integral that we're going to use?
Negative 3 to 0.
-3 to 0. And are we doing a positive f of x or a negative f of x? Positive, okay? So it's because f of x is on the top, so it's that minus the 0. So it's x cubed plus 2x squared minus 3x dx. Okay? Then we're going to add the integral from 0 to 1, and here's where you can view it as, okay, the line y equals 0 is on top, so I need to subtract this. Okay, so here we're seeing something that we have done before. We just did it a little bit differently, but it's really just an application of what we're looking at here with the area between two curves. Okay? And then you can find those integrals. Okay, x to the 4th over 4 plus 2x cubed over 3 minus 3x squared over 2, evaluated from negative 3 to 0. And then I'm going to pull that negative out in front, so it's going to be minus the same thing, x to the 4th over 4 plus 2x cubed over 3 minus 3x squared over 2, evaluated from 0 to 1. I just pulled the negative here from the 0 minus this.
Oh, okay.
I just pulled that out in front.
Oh,
Okay. Okay, so now we just have to evaluate a few things here. If I plug in 0, I get 0. If I plug in a negative 3, I'm going to get 81 over 4 minus 18. That's going to be 2 times 27 over 3, 2 times 9. Minus 27 over 2. Okay, so that's evaluated at negative 3. Then I have minus, if this is evaluated at 1, I have 1/4 plus 2/3 minus 3/2. Minus this evaluated at 0 is 0. Okay. So now we just got to put things together here. Negative 81/4 minus 1/4 is a negative 82/4. Positive 18 minus 2/3 plus 18 minus 2/3. With the halves, it's a positive 27 halves plus 3 halves, so that's a plus 30 halves. Okay. So that's 15. This is 82 divided by 4 is, that's going to be a minus 20 and a half. Okay. So let's see, what do we have here? Let's see, that's going to be a minus 21 and 1/6 plus 33. So that's going to be 11 and 5/6. Okay, so that's our total area enclosed. Okay. All of this is just the arithmetic. You guys could figure that out however you want, but does everyone understand the how we set that up, how we got the integrals and use that to find the areas? You got it?
I have a question.
Yes.
Like, on the previous one, we can combine them together to find to find their integration together. Can we also do for this one?
This one, because one was positive and one was negative, we couldn't like combine them together like that.
Okay.
Like we couldn't do the integral from -3 to 1.
Oh, we can.
No, because part of that goes below the x-axis.
You have to do them separately.
So you have to do them separately.
But for the previous one, since they are all on the same, all over the y-axis, so we can do that together.
Well, the previous one, you could combine,
Oh, because that is two functions, but this one is just one function.
yeah, there were two different functions. Here, we were kind of treating the line y equals 0 as the second function.
I got it.
Okay.
I got it.
Okay, so at this point, I've just got some practice here for you, okay? I would highly recommend sketching these, alright? But notice, you're not given the graphs necessarily for these, okay? So just practice working through some of them. Find the intersection points, determine the intervals, then determine which one is on top in each interval, and then do the subtraction, top function minus the bottom function. Okay? So there's a little bit of practice. Some of these they gave you some help with. Alright, so, and then the last ones especially, those last ones have some good problem solving there. You got to adapt what we learned to a slightly different situation. Okay?